And Abhinav, is it possible we can enable the AI companion like for the notes for this lecture? So that will be useful.
AI companion in Zoom.
Yeah, I can see ask host to summarize the meeting. Let me ask you. Did you get any?
Mm-hmm. Yeah, accepted it.
Mm.
Okay.
So it will summarize whole complete lecture.
Okay.
Mm.
Yeah. Just sharing my screen.
Mhm.
So we will be discussing neural networks and deep learning. So in this, what we will be discussing is basically the human and machine analogy, which we had discussed when we were starting AI. Just a revision of it. Then what is biological neuron? And different aspects of biological neuron. Then after that, we will discuss what is artificial neuron. And artificial neuron, basically, in this, we will be discussing perceptron model. Perceptron model is divided into two, where we will discuss on what is single perceptron model and then multi-layer perceptron model. And after that, uh, what is basically a neural network? And after that, what are known, what is the concept of activation function? Then there is a concept of back propagation. So these are these are some of the concepts that we will see, and then probably tomorrow we will build the artificial neural network using Python, and we'll see how it works. Okay, so the first thing, right? Human and machine analogy. So when we're talking about human and machine analogy, so we know, right? So artificial neural network. So when we talk about artificial neural networks, it is basically a computational model, right? These are inspired by biological neural networks. And biological neural networks means, the science behind it is basically neuroscience. And artificial neurons are is inspired from biological neurons. And then finally, deep learning is something which involves artificial neurons and artificial neural networks, and it is basically inspired from how human brain learns using deep layers of biological neurons. Now, let me share my screen from my iPad and I'll try to showcase you the biological neuron and the related concept. I'm trying this out first time. Let's see how it goes. Okay. So I'm just started sharing my screen. Let's see. Flexel. Okay. Give me a second. I'm just figuring out a few things. Okay, that's fine. Okay, cool. So what we were discussing? We were discussing about biological neuron. So biological neuron. So how does it basically look? We will see that. So biological neuron, when we talk about biological neuron, so it basically consists of dendrite, nucleus, and axon. So if I'll draw the biological neuron, it will somehow look like this. Okay, I don't think whatever I'm drawing is not being broadcasted, right?
Yes, it is little delay. I can see you have written biological neuron.
Hmm.
Yeah, now it is loading.
We'll see if it is. It will be
It's
delaying.
showing, but there's a lot of latency, it seems.
Hmm.
Yeah, it is delay.
Hmm. ठीक है. So let me do one thing. Let me share from my original screen only because I am drawing something. It is not being broadcasted.
Hmm.
Or let me try out once again, just resharing it again.
Yeah. Hmm.
Let's try it out this time.
Yeah, it's.
So this is basically biological neuron, and this is known as soma. So soma is nothing but a cell body. Okay. Now these things that you can see here, right? These are basically dendrites. These are dendrites. These things. And this particular thing is known as axon. And this in the middle, this is basically known as nucleus, right? So this is a biological neuron, how biological neuron looks. And at the end, what you can see here at the end, this particular point, this is known as synapses. So synapses is nothing but a connection point between two neurons. Means what will happen? So this is single, neuron. So what will happen? This particular at synapses, dendrites of other neurons will be basically, uh, you know, that will be connected here, and then there will be another neuron with, nucleus, another nucleus, and then another axon, like this, something like this. So this is a connection point. Now, what is the basic of the biological neuron? So biological neuron basically receives signal through, okay, so first of all, it receives signals through dendrites, right? So dendrites are nothing, as I told, right? These are the projections, branches coming out of cell body that catches electrical signal. Then we have cell body, right? Cell body or soma. So it processes the signal. What is its main function? It processes the signal that gets received. And then third part is axon, right? Axon basically carries out output signal to next neuron, right? So this is the basic of human biological neuron, I would say, not human, biological neuron. Now, synapses, if you can see here, synapses, right? So if I'll draw synapses more closely, so synapses, how does basically synapses, you know, function? So let's say this is an axon, right? Axon of one neuron. And then this is the dendrite of next neuron. So this is dendrite, this is axon, right? And this little gap here is basically synapses. So it never touches, basically. There still is a gap between them, and that gap basically, this particular gap, this is known as synapses cleft. And what happens is that electrical signals are carried from one neuron to another neuron using this synapses, and this whole middle part which I have encircled is basically collectively known as synapses. Now, the signals are basically transmitted as part of neurotransmitters. So यहाँ से neurotransmitters are basically transferred in the synapses through the synapses cleft, and then dendrite of the next neuron basically catches it. So in terms of biological language, so neurotransmitters are nothing but the chemical messenger released from one neuron's axon terminal into synaptic cleft. Synaptic cleft is the tiny gap between neuron, and the amount of neurotransmitter released and how sensitive the receiving neuron, this can be this can basically modulate how strong the connection acts. So higher the signal strength, more next neuron activates. Here neurotransmitters are dopamine, serotonin, right? You might have heard. So this is the basic of biological neuron basically. So it depends on the connection, how the connection between the axon and dendrite is. More the connection, the strength of the connection, better the transmission basically happens, or in other terms, we say more next neuron activates. So this is about the biological neuron, right? Now let's discuss about artificial neuron. So talking about artificial neuron. So artificial neuron ko we call it as perceptron also. Okay. So a perceptron was a form of neural network introduced in 1958. It was, discovered long back in 1958 by the person named Frank Rosenblatt. But in 1969, some paper got published and it suggested that there were severe limitation of what perceptron can do. And they told that it basically lacks, there is a lack of computational power. And then what happened? So I'm talking about 1969. So from 1958 to 1969, I mean, neural network and the concept of deep learning were already introduced in the world. But what happened in 1969, start of the 1969, around in 1970s, that period is basically known as AI winter. There were no funding basically given to the AI projects. No funding was there, and I mean, government was not supporting AI and neural networks in 1970s. So this I'm talking about 1970s. If government would have supported the growth of AI and neural network in 1970s and funded in this area, we might be, much ahead uh, by now, right? It's just that in 2000, this again, got into picture, and then, proper neural network development and AI development happened. So that was the background of artificial neuron, how it was basically introduced. And as I said, right, artificial neuron is inspired from biological neuron. Biological neuron ko we call it as, nerve cell also. So abhi artificial neuron, how does it basically look? Let's see that. So when we talk about artificial neuron, so it basically contains node. Biological neuron में क्या था? There was nucleus, right? यहाँ पे it is node. So node को हम fx से denote करते हैं. Let's denote it as fx, and it receives some input. So input means जैसे in biological neuron dendrites were there, right? यहाँ पे this node is receiving input. Let's say some input x1, x2, and it has weight as w1 and w2, and it basically produces output y, is known as output. And यहाँ पे if we'll talk about y, so y is basically w1 x1 plus w2 x2 in layman terms. Okay. Now basically when we talk about artificial neuron, so artificial neuron ka when I'm talking, so neuron means when we talk about neuron, it is also known as node or perceptron. I mean, these terms are interchangeably used. And what is neuron basically? It is basically it is a basic computational element where math happens, right? Where math happens means whatever is the use case. For that use case, if we are creating any neuron or any artificial, networks, so neuron or node is something where it is a basic computational element where actual math happens behind the scene. And each neuron means this particular part. This is a whole neuron, right? So each neuron is basically, it's like a tiny computer. Okay, it's like a tiny computer. And artificial neurons have, lot of neurons, lot of, artificial neurons in their neural networks. Now, if we look closely, this particular equation ko if we are looking closely, so यहाँ पे we can basically adjust weight. First point is that we can adjust weight W1, W2 to affect the output or to get the correct value of the of y. So basically, we can adjust W1 and W2 to basically uh, get the correct value of y. 1 second. Right? Then second point is that what happens if x becomes 0? When we make x equal to 0, in this case, what happens? So any value of w won't change anything, right? As soon as x becomes 0, so any value of w won't change anything. W को 100 कर लो, 1000 कर लो, but if x is 0, it is like 0, right? Now, in order to tackle this particular challenge, so that when x becomes 0, it basically don't fall apart suddenly. In that case, in order to tackle this, what we do, we basically add bias term. We add bias term. So bias term, let's denote it by small b. So we basically add the bias term with each input and weight. So what will happen when we add bias term? The equation will become something like this: y equal to x1 w1. So in input x1 we are adding one bias term b1, and then in second x2 w2 we are adding another bias term, right? So this is how the basic perceptron, single perceptron model basically comes into picture. Why it is single perceptron model? Because there is only one.
Okay, I found this on the web for by single perceptron model.
My Siri is listening. 1 second. Okay, so this is because there is only single neuron under, I mean, in this particular situation, we are just discussing about single neuron. Hence, it is known as single perceptron model. So mathematically, we can generalize this as, if we are making predictions, so y cap equal to sigma and I equal to 1, and n are total inputs that we want to take, and then xi wi plus bi. So this is the mathematical equation of single, basically single perceptron model. Okay. Now, any doubt in this?
No, it's fine.
Okay. Now, this theoretical concept you need to understand very well before you actually start doing the coding, Python coding, because otherwise, if without understanding these concepts, if you'll directly jump onto the coding, it will become a little difficult to map different points. Okay. Okay. 1 second. Hmm. Okay, now let's talk about multi-layer perceptron model. I'm just trying to add a new page here. Give me 1 second. Okay. Okay. Now what we are going to discuss is multi-layer perceptron model. So we are still discussing artificial neuron, right? We are still discussing artificial neuron. And now what we are doing, we will be discussing on multi-layer perceptron model. Okay. So a single percent perceptron is basically not enough to learn complicated system, right? That is where the concept of multi-layer perceptron model came into picture. Now, what we can basically do is that we can expand on the idea of single perceptron to create multi-layer perceptron model. And to build a network of perceptron, we can connect layers of perceptron using multi-layer perceptron model. So how multi-layer perceptron model looks, let's see that. So let's say that we have different nodes. This is first node, this is second node, this is third node. And this is basically the input layer, right? Now let's create some more nodes in next layer. Let's say we are creating these nodes and like this. Okay. Now what is happening is that this particular thing is known as hidden layers. This is known as this particular layer. This is known as input layer. And this one last is known as output layer. Now from input layer, each input layer, each of these node basically receives some input. And then each node is connected to every other next node like this. Similarly, like this. Sorry, like this. And this node to next nodes. Similarly, these hidden layer nodes, each node is connected to every node in the next layer like this. And then finally, it will converge to the output node. Okay. Okay. Again, this sharing did not happen. Let me reshare it again.
Yeah, it is stuck.
Okay. ठीक है. So this is how a multi-layer perceptron model basically look. यहाँ पे every neuron in one layer is connected to every other neuron in next layer, and layer between input layers and output layer is known as hidden layer. So this hidden layer, there are two hidden layers in this case, but it can be like anything, right? It can be hundreds of hidden layers also, and it depends on your use case how many hidden layers you want to keep basically. Now, when we talk about these, neural networks basically. So we were talking just neurons right now, artificial neurons. When we talk about neural networks, so building blocks of each neural network is neuron, right? What are neurons? So these things are neurons, right? These circular things, nodes. These are neurons. And neural network contains single neuron. So this neural networks, whatever we basically, any network that we will see, neural network, it can contain either single neuron or it can contain multiple neurons. So basically, single neuron we have seen it is known as single perceptron model. Multiple neurons is basically something that we are seeing on this screen. Now, multiple neuron basically, okay, I think let me share my screen from the original laptop. There is still some lagging, and let me stop sharing from here. And let me share from my system. Okay, what I was telling is, so we are talking about neural networks. So neural networks are divided into networks, one containing single neuron, other containing multiple neurons. So single neuron, we have seen single perceptron model, right? Multiple neuron, what happens? So multiple neuron, where there are multiple neurons, we can call that neural network as shallow neural network, or we can call it as deep neural network. Now, shallow neural network means where hidden layers, we have just one hidden layer. And deep neural network is something where we have more than one hidden layer. So shallow and deep terms are used whenever there are hidden layers involved, right? And if there is no hidden layer, like in single perceptron model, then we cannot use the word shallow or deep. Now there are other terms also, like width of neural network. So when we talk about width of neural network, it is basically something defined with how many neurons are there in the layer. And when we talk about depth of neural network, so depth of neural network is something uh, which we can find out with how many layers are there in total. So this is about some terminologies that we used in multiple neurons. I mean, in neural networks, where we define shallow neural network, deep neural network, what is width of neural network, and what is depth of neural network. Okay. Now we have seen, right? So there are basically how many types of layers we have seen? First was the input layer, second was the hidden layer, and third is output layer. These are the layers that we have seen, right? So the job of input layer is to simply pass the data. Data means features, right? Feature, pixel, or whatever, into the network or into the hidden layers, we can say. And the first hidden layer is where the network start transforming the data. And how this transformation happens, that I'll cover up later on when we'll discuss about the maths of these neural networks. Then when we talk about hidden layers, so there is something known as activation function, right? What is activation function? I'll come to that in some time. So when we talk about activation function, so in input layer, no activation function is applied on input layer. Hidden layer पे activation function starts applying from first hidden layer, and then output layer. So on output layer, activation function on output layer depends on what kind of problem it is. Whether we are trying to solve regression or we are trying to solve classification problem. Now let's talk about activation function. So what is basically the activation function? So activation function is basically a mathematical operation used in neural networks. So it's nothing but a mathematical function, I would say, or let's say operation. Where it is used in neural networks. And why it is used? It is used to determine whether a neuron should be activated. If you remember in biological neurons, we were discussing, right? The strength of the signal basically decides whether next neuron needs to be activated or not, right? So here, the activation function similarly means do the similar things. So it basically determines whether a neuron should be activated or not. Now, when we talk about activation, so activation का मतलब है, activation means it decides whether it should pass the information forward in next layer, and how strongly it should respond to the input. Okay, so by deciding on which activation function to select in layer, we can decide how strongly the neuron should respond to the input. Now, without activation function, so when we don't include activation function, so in neural network, it will be, just a stack of linear operation, meaning no matter how many layers it had, it could only model linear relationship, right? So activation function is basically used to add the non-linearity also. So why we are adding non-linearity? So non-linearity allows network to learn complex patterns like images, speech, and language, right? Now, when we talk about activation function, and before that, how it basically is applied. Let's say हमारे पास we have y uh, let's say fx is some function having some values, right? So let's say something w1 x1 plus x1 square, anything. I'm just taking a random example, okay? Like this. There is something known as fx. Now, when we apply activation function, what is the activation function? So sigmoid is one of the example of activation function. So sigmoid function is, it is defined as 1 divided by 1 plus e is to the power minus x, ठीक है? तो 1 upon 1 plus e की power minus x is the sigmoid function. Now, when we applied activation function, so this is known as activation function. Sigmoid is an activation function. Now, when we apply activation function on some output, let's say fx is the output, तो यहाँ पे क्या करेंगे ना, x की value will be replaced with this particular expression, this. So fx, ये w1, so fx is w1 x1 plus x1 square. Let's say I'm taking just just a hypothetical example. So जब this is the output and we want to apply activation function on this, so what we will do, we want to apply sigmoid activation function on this. So what we will do, we will pass this and treat it as the, well, as basically the x when we apply the activation function. So यहाँ पे 1 plus e is to the power minus and x की जगह पे जिस पे भी हमें एक्टिवेशन फंक्शन लगाना है, दैट थिंग विल कम. सो इट विल कम एज w1 x1 प्लस x1 स्क्वायर. सो ये एक लेयर पे एक्टिवेशन फंक्शन लगा, तो उस लेयर का आउटपुट ये हो गया. एंड देन उस पे जब लगाना है, देन नेक्स्ट लेयर पे, तो देन इट विल बी ट्रीटेड एज एक्स, एंड देन वॉट एवर एक्टिवेशन फंक्शन वी वॉन्ट टू अप्लाई, वी विल अप्लाई इन द सेम मैनर गोइंग फॉरवर्ड. सो दिस इज द कंसेप्ट ऑफ एक्टिवेशन फंक्शन. अब यूज क्यों करते हैं, राइट? लेट्स टेक एन एग्जाम्पल ऑफ सिग्मोइड. सो सिग्मोइड का एग्जाम्पल व्हेन वी विल टेक, ये एक्स एक्सिस हो गया, ये वाई एक्सिस हो गया, मतलब एक्स की वैल्यू माइनस इन्फिनिटी से इन्फिनिटी इज possibility, right? Minus infinity से infinity. ठीक है. And before activation function, let's say ये वाला expression था हमारा, right? This is the expression w1 x1 plus x1 square, which is y basically, right? So before applying the activation function I am talking, तो y की जो possibility थी, that is again minus infinity to infinity है, right? Minus infinity to infinity. Value can be minus infinity to infinity. Now, as soon as we apply activation function sigmoid, तो sigmoid का graph कैसे होता है? Let's see that graph first. So sigmoid graph is something like this, where ये वैल्यू जीरो हो गई, यहाँ जहाँ पे कट करता है, दिस इज 0.5, एंड मैक्सिमम वैल्यू नेवर क्रॉसेस 1. तो मैक्सिमम वैल्यू जो है इट कैन बी 1. तो ये वेन एवर वी हैव अप्लाइड एक्टिवेशन फंक्शन, तो यहाँ पे फर्स्ट ऑफ ऑल y की जो वैल्यू थी माइनस इन्फिनिटी टू इन्फिनिटी इज द पॉसिबिलिटी. एज सुन एज वी अप्लाई द एक्टिवेशन फंक्शन इन दिस वे, राइट, y पे, सो ये इस वाले ग्राफ को इट विल रिप्रेजेंट. दैट मीन्स कि फ्रॉम माइनस इन्फिनिटी टू इन्फिनिटी वी हैव स्क्वाश्ड द आउटपुट जस्ट बिटवीन 0 and 1. कुछ भी वैल्यू होगा x का. For any value of x between minus infinity to infinity, we have squashed the value, output value between 0 and 1. So that is why we basically apply activation function where we want to limit our output to some certain value, certain range of value, and we basically introduce non-linearity, right? That way, the neural network will basically learn the complex patterns. Now, sigmoid is one of the activation function. Then there are many activation functions. So let me.
I have a doubt. Can we use multiple activation functions in multiple layers?
In one layer, you can use one activation function. In next layer, you can use different activation functions. So all nodes in one layer, for all nodes in one layer, you have to use a single activation function.
Nodes and neurons are the same thing, right?
Nodes, neurons, perceptron, all are the same. मतलब कि ये hidden layer, first hidden layer पे there are 3 nodes. Second hidden layer पे there are 2 nodes. Third hidden layer पे there are again 3 nodes. So in these all nodes, you will use activation function 1. Same function on all the nodes. In this,
Nodes are basically the input features, or
nodes are these circles, which are like tiny computers, you can say, right? Which receives some input and it produces output. So similarly, second hidden layer पे you can use another activation function A2, but that needs to be applied on all the nodes in this particular layer. So when we talk about activation functions, so these are some of the activation functions available. Sigmoid is one, right, that we have seen. Then 10H. 10H basically limits the output from -1 to 1. Leaky, ReLU, ELU, ReLU. There are many. And with different use cases, you basically select these different activation functions. Okay, now let's talk about the network part and what kind of activation function you can apply. So when we talk about input layer, okay, when we talk about input layer, there on input layer, we don't apply any activation function, no activation function. Input layer pe we don't apply. Hidden layer. So hidden layers pe we basically generally applied ReLU, then leaky ReLU, then 10H, etc. And as you asked, right, so same activation function is applied to all the neurons in one hidden layer. Then we talk about output layer. So when we talk about output layer, so there are two things that we want to do, right? First is classification problem we are basically looking. Second is regression, right? These are the two things that we want to do. So classification pay uh, when we basically focus on binary classification. So when we talk about binary classification, we basically use sigmoid function. Sigmoid function क्या करता है? It squashes the output between 0 and 1. अभी binary classification को when you see, so binary means yes or no, spam, non-spam, male, female, something like this, right? So there are only two possibilities in binary classification. So when we applied sigmoid function, so it basically limits the output between 0 and 1. 0 and 1 का मतलब it basically turns your output into probabilities, right? So output can be any value between 0 and 1. That means output is kind of a probability. 0.9 output आया means high probability for that particular classification, right? 0 आया तो 0 probability. So it basically squashes the output into between 0 and 1. Similarly, when we talk about multi-class classification, so multi-class में भी we basically apply softmax. ठीक है? क्या होता है softmax? एक बार let me, I'll just show you. Regression में क्या करते हैं when we apply basically when we are approaching for regression problem, we either don't apply any activation function or uh, none or linear, we basically say, because we want to limit our output to minus infinity to infinity, right? Like regression it can be anything. So this is the basic of applying activation function on different layers. Softmax ka I wanted to show you softmax, right? Softmax again, so softmax is so yeah, I was talking about probabilities. So softmax is where it turns the output into probabilities. So it is like something like this. I don't want to show you this because it will scare you when you see a lot of mathematical formulas on this. But yeah, basically, yeah. So if you want to see softmax, so this is softmax function. Softmax function का graph, if you will see softmax graph, so it is basically limiting the output between -1 and 1, basically. Okay, but there are again, so there are different representation of graph. Sometimes they don't start 0, 0 पे. They will basically you know, यहाँ पे जैसे देखो आप, यहाँ पे 0 is starting here, not here. So when you will see graphs on internet, so although the graph will be correct, but if they will change the axis x and y axis from 0, it will look different. So basically अगर हम y axis यहाँ पे बनाते तो softmax का graph will basically look like this. So just whenever you will try to understand these functions or when you do some research from your side, just remember that x की value 0 is sometimes they don't represent on the starting point here. ठीक है? Okay, I don't want to overcomplicate this. So this is the example of the activation function. Okay. Okay, now let's do one thing. So we'll wrap up our class here itself. So I just want to cover the theory. Now, what we will do in tomorrow's class, we will discuss on the maths of the activation function. So, whatever we have learned, so single perceptron model and then multiple perceptron model pe, we will apply the activation functions and we'll see how it basically work. And once that is clear to you, once you'll get some understanding on that, then we will start the Python coding on building various hidden layers and then, working on different problems using neural network. Cool. Any doubt before we wrap up? I just want to wrap up quickly today because there are a lot of concepts that I have told you. It's just the theoretical, session today, but it's very important for you to build this, mindset of neural networks and deep learning before we move forward with the actual, demonstrations. Any doubts?
No, no.
Can you please repeat a depth and what was the width of
Width,
that?
yes.
Yeah.
So width of neural network is how many basically neurons are there in a layer.
In a layer, in a
Hmm.
single layer,
Hmm.
not all.
Yeah, yeah, yeah. And
Okay.
then depth of neural network is how many layers are there
Um,
in total.
okay.
So if three hidden layers, one input layer, one output, so depth is 5.
Hmm.
And similarly, width is if first hidden layer mein there are three neurons, so the width of first hidden layer is 3.
3. Okay.
Hmm.
So width will be calculated layer wise.
Hmm. Right.
Okay.
So actually जो हमने whatever diagram we have made ना हमने ऐसे बनाया था, correct? This is input layer, this is hidden layer, and then this is
Hmm.
output layer. But actually में इसकी जगह ऐसे बनता है, ऐसे होगा, ऊपर से input आ रहा है, like this, x1,
Hmm.
x2, then hidden layer आई, then दूसरी hidden layer आई, then we have output layer. So ऐसे इस तरह से flow हो रहा है data. So this is known as depth. Depth means how many layers are total. So one layer, two layer, three layer, four layer. So depth हो गई 4. And then width, this is width basically. हर लेयर की अपनी अलग width होती है. So first hidden layer, what is the width? It is 3 here. इसमें it is
Hmm.
2,
2.
like this.
Okay.
Okay, cool. Then we'll see. We'll meet tomorrow and we'll see the mathematics behind activation function. Hmm?
Yeah.
Okay. See you.
Okay.
Bye bye.
Thank you. Bye.